In this example, we're given a polymer molecular weight distribution. We want to calculate the average molecular weight, and we're going to calculate two types of averages, a number average and a weight average. And then if the molecular weight of the repeat unit of the essentially the monomer that ends up in the polymer, if that molecular weight is 56, then calculate also the degree of polymerization. So this graph shows the fraction of the polymer that is in the molecular weight range from 8 kilograms to 20 kilograms per mole, and then a different fraction from 20 to 32, so forth. So these fractions add up to 1. This is just a simplified, idealized example to make it easier to see the numbers. And we're going to then use this data, which is shown here in tabular form, to calculate the molecular weight. So what we want to do is calculate the number average molecular weight. We'll use this notation. And this is equal to the sum of the fraction times the molecular weight of that fraction. So this then would be the average for the range. So for example, from 8 to 20, the average is going to be 14. From 20 to 32, the average is going to be 26. So halfway in between. And what we're going to do then is use these numbers, this average, the weight fraction, calculate the average molecular weight. So I've done the multiplication here. If I multiply these and add them together, I get 47.7 kilograms per mole, or 47,700 grams per mole. This is the number average molecular weight. You can also calculate a weight average, which is the sum of the weight fraction times this average molecular weight for each region that we have in this data set. This means first we need to calculate the weight fraction. So the weight fraction is going to be xi times mi divided by the average, namely 0.05 multiplied by 14 divided by 47.7. That's the weight average for this first set of data from 8 to 20. So what we've done is calculate the weight of that region and divide it by total weight. And so we do the equivalent for these other terms. We can get the weight fractions. And so I'll just list the weight fractions here. So I've calculated the weight fractions just by this exact calculation for each of these. Now I can take the weight fraction and multiply it by mi to get the weight average molecular weight. So I've listed here the average molecular weight, the weight average, the product, and then if I do this multiplication and then do the summation, I get 53.9 kilograms per mole, or 53,900 grams per mole. 53.9 kilograms per mole is the weight average molecular weight. So notice the weight average is larger than the number average. That's to be expected. We're putting more emphasis on the larger polymers. And then we can use this to calculate a couple things. The first is the polydispersity. This is just the weight average molecular weight divided by the number average molecular weight. So 53.9 over 47.7, 1.1. So this is an indication of how broad the distribution is of the molecular weight. And this is a fairly narrow distribution. The last thing we're going to calculate is the degree of polymerization, which is indicated by this symbol. And what this is going to be is the number average molecular weight divided by the mass of the repeat unit. So this is the mass of the repeat unit, which in this problem we said was 56. So units consistent. This is grams per mole. This is 56 grams per mole. So what this corresponds to is the average number of repeat units in the polymer. So we've shown we can calculate two types of average molecular weights. We can also calculate something that indicates the broadness of the distribution, and then we can calculate the average number of repeat units in the polymer.